Time. It's a word we use every day, yet it remains one of the most elusive concepts in human understanding. What is time? Is it real, or just a construct of our perception? For most of us, time is measured in seconds, minutes, and hours, but these units barely scratch the surface of its complexity. Philosophers have debated its nature for centuries, from Aristotle to Kant, asking whether time exists independently of events or if it is merely a sequence of perceptions. In ancient civilizations, time was often viewed cyclically, reflected in the seasons and agricultural cycles. The Egyptians, for instance, measured time by the flooding of the Nile, while Mayans had complex calendars celebrating celestial events. However, as human societies evolved, so did our understanding of time. In the 14th century, the advent of mechanical clocks marked a significant shift, providing a way to quantify time more precisely. However, it wasn't until the 17th century that thinkers began to grasp time in a more scientific context. Sir Isaac Newton posited that time was absolute and the same for everyone, a continuous flow that could be measured. But the Industrial Revolution forced a re-evaluation of time once again, as society adapted to synchronized schedules that highlighted time's relentless march forward. The introduction of standardized time zones and the railway systems demanded accuracy that had not been required before. Yet, Newton's view of time would soon be challenged. In the early 20th century, Albert Einstein introduced a groundbreaking idea: time could bend. According to his theory of relativity, time is not a constant but varies depending on speed and gravity. Imagine standing on the surface of a massive star, where gravity is so strong that time itself crawls. Meanwhile, someone floating far away in space would experience time passing normally. This leads us to time dilation, a phenomenon proven by experiments where atomic clocks on fast-moving planes or satellites tick slightly slower than those on the ground. The consequences of this have profound implications for technology and our understanding of the universe. As we delve deeper, we find that time is intricately linked to the very fabric of the cosmos. Time, as we understand it, is a fourth dimension woven into the fabric of space, creating a space-time continuum. But does time exist if no one is there to perceive it? As we ponder these questions, we must prepare for a journey that takes us through the history, physics, and philosophy of time, revealing that it's not just a measurement but a fundamental part of our existence. What if I told you that the future might not be as set in stone as we believe? Stay tuned as we explore the surprising ways in which time can be perceived and manipulated. To understand time, we first need to understand how humanity has measured it throughout history. The very concept of timekeeping has evolved from simple shadows cast by the sun to the atomic clocks defining our modern world. Ancient Egyptians used sundials to mark hours, while water clocks, or clepsydras, were used in various cultures to measure time with a certain precision. As civilization progressed, the need for more accurate timekeeping led to innovations like the mechanical clock in the Middle Ages. These ingenious devices transformed time from a natural phenomenon to a controllable entity, allowing for more structured lives. In the 16th century, Galileo Galilei discovered the isochronism of pendulums, which paved the way for precise pendulum clocks. By the late 17th century, the first reliable pendulum clock was built by Christian Huygens, marking a revolution in timekeeping. These developments not only impacted daily life but also influenced navigation. Sailors depended on accurate timekeeping to chart their courses across the oceans, leading to the creation of marine chronometers. But with progress came challenges. The introduction of time zones in the 19th century was an attempt to standardize time across vast regions, driven by the expansion of railroads. Before this, cities often set their own local times, leading to confusion and accidents. When the International Meridian Conference was held in 1884, it was decided that the prime meridian, located at Greenwich, England, would be the starting point for global timekeeping. This marked the birth of the global time zone system. By the 20th century, precision reached astounding levels with the advent of atomic clocks. These devices use the vibrations of atoms to measure time with incredible accuracy, to the point where they can measure seconds that are billions of years old. This leap in technology not only refined our understanding of time but also solidified its importance in scientific research, global positioning systems, and the technology sector. The evolution of timekeeping also raises philosophical questions about our perception of time. Is our linear measure of time an accurate representation of how we experience reality? The discrepancies between objective measures of time and personal experiences can lead us to wonder if time itself behaves differently in our minds. What if the way we perceive the passage of time is not universal? Consider how time appears to speed up as we age or slows down during moments of danger. In the coming chapters, we'll explore these phenomena further, but first, let's reflect on the implications of how we measure time and the impact it has on our lives. As we ponder these ideas, we must question not just how we measure time, but what it truly means. Could our understanding of time evolve once more as we dive deeper into its mysteries? There's more to discover as we move into the realm of time perception. As we continue our exploration, we find ourselves at the intersection of time and consciousness. How do we, as humans, perceive time? Our understanding of time is not just a scientific concept but a deeply personal experience shaped by our minds. Cognitive psychologists have delved into the intricacies of time perception, revealing that it can be influenced by numerous factors, including age, emotion, and attention. Research shows that our perception of time can warp. For instance, a minute spent in danger feels much longer than a minute of boredom. This phenomenon is illustrated in a famous study where participants were asked to estimate time intervals. Those experiencing heightened emotions, like fear or excitement, tended to perceive time as elongating. Conversely, when engaged in enjoyable activities, time seems to fly by. This sense of time distortion can lead us to question whether our conscious experience aligns with the objective measurement of a clock. Have you ever felt like time slipped away while engrossed in a book or a movie? In the realm of developmental psychology, studies indicate that children experience time differently than adults. Young children may perceive time as more fluid and less structured, which changes as they age and their cognitive abilities mature. In addition to age, our biological rhythms significantly affect time perception. From circadian rhythms to innate impulses, our bodies are wired to respond to time in ways we may not even realize. For example, research has found that time perception can be altered by sleep deprivation, with sleep-deprived individuals often reporting time intervals as longer than they are. Moreover, cultures around the world also have unique approaches to time. For instance, some cultures view time as flexible, valuing presence over punctuality, while others prioritize strict adherence to schedules. The implications of these studies extend beyond the individual. They challenge the shared understanding of time in society. If our experiences of time vary so widely, what does that mean for our interactions with one another? As we contemplate these nuances of human experience, consider the idea that time is both a shared construct and an individual perception. As we inch closer to the quantum realm, we will see how these concepts intertwine and affect our understanding of time on a universal scale. One of the most mind-bending concepts in modern physics is time dilation. This phenomenon, a direct consequence of Einstein's theory of relativity, shows us that time is not a constant but can vary depending on speed and gravity. Imagine traveling close to the speed of light. Your perception of time would slow dramatically compared to someone standing still. The classic thought experiment illustrating this is the twin paradox. If one twin travels into space at near light speeds while the other remains on Earth, upon their reunion, the traveling twin will be significantly younger than their Earth-bound sibling. This idea seems straight out of science fiction, yet it is a well-supported principle of physics. One of the most famous real-world applications of time dilation is found in GPS technology. Satellites orbiting Earth experience less gravitational pull compared to those on the surface, causing their internal clocks to tick slightly faster. Engineers account for these subtle differences to ensure that GPS systems are accurate. Time dilation isn't just a theoretical concept, it has practical implications, as evidenced in experiments involving atomic clocks placed at varying altitudes. When scientists compared these clocks, they found time indeed passed differently, confirming Einstein's predictions. The implications of time dilation extend into the realm of black holes as well. Near a black hole, the gravitational forces are so immense that time effectively stops for an observer. If one could hover near the event horizon, they would witness flashes of light from the universe's history while only seconds might pass for them. As we ponder these complex ideas, we must consider how time dilation reshapes our understanding of reality. If time can bend and shift, fundamentally altering how we experience and measure it, we are left with an unsettling thought: does the future already exist in some form? Stay tuned as we explore the connection between quantum mechanics and the very nature of time itself, revealing secrets that challenge our understanding even further. As we dive deeper into the universe's mysteries, we find ourselves at the doorstep of the quantum realm, where the rules of time become even more perplexing. Quantum physics, with its strange and counterintuitive principles, challenges our classical understanding of time. In this realm, time can appear to behave in bizarre ways, raising the question: is time actually an illusion? One of the most intriguing concepts in quantum mechanics is that time might not exist at all in the way we perceive it. Some interpretations suggest that at the quantum level, events do not occur in a linear fashion. Instead, they may exist simultaneously in a sort of block universe. Renowned physicist Carlo Rovelli argues that time is a measure of change rather than a fundamental aspect of reality. In his view, the concept of now is merely a human perception, and the flow of time is an illusion born out of our consciousness. In addition to Rovelli's ideas, the phenomenon of entanglement poses a fascinating challenge to our traditional perception of time. When particles become entangled, the state of one particle can instantaneously affect another, regardless of the distance separating them. This questions the idea of cause and effect, which is so central to our understanding of time. Furthermore, researchers like physicist Sean Carroll have explored the role of entropy concerning time. Entropy, which measures disorder, increases over time according to the second law of thermodynamics. This suggests that our perception of time moving forward is tied to the universe's tendency towards chaos. As we grapple with these challenging concepts, we are forced to confront the implications of a timeless universe. If time is indeed an illusion, what does that mean for our understanding of life, death, and existence itself? What if the past, present, and future are all unfolding simultaneously? The answers may lie in the uncharted territories of both science and philosophy, inviting us to rethink everything we thought we knew about time. As we prepare to explore the philosophical implications of time in our next chapter, the question remains: how does this newfound understanding shape our lives and reality? The concept of time is deeply intertwined with the very fabric of our existence. One of the most intriguing aspects of time is its irreversibility. It flows in one direction, from the past to the future. This phenomenon is often referred to as the arrow of time. But why does time only seem to progress forward? Why can we remember the past but never the future? To understand this, we must delve into the realms of physics and thermodynamics. In thermodynamics, the second law states that in any energy exchange, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state. In simpler terms, systems tend to move towards a state of disorder or entropy. Imagine a glass falling and shattering on the floor. The chaos that ensues, the scattered shards of glass, represents a greater state of entropy compared to the intact glass sitting on a table. As we move forward in time, we witness processes like aging, decay, and the eventual wearing down of systems, all of which manifest the arrow of time. But the arrow of time isn't just a concept from physics. It influences our daily lives and our very perception of reality. In 1973, renowned physicist Stephen Hawking proposed the idea of time as another dimension, much like space. He suggested that just as we can move freely in three-dimensional space, we are constrained to move in one direction when it comes to time. This theory poses several philosophical questions. If we could somehow reverse entropy, could we reverse time? Would we be able to relive lost moments? To illustrate the concept, consider the famous thought experiment known as Maxwell's demon. Imagine a creature that can sort particles in a gas by energy levels, allowing some to pass through a barrier while preventing others. In doing so, this demon could decrease entropy and seemingly reverse time. However, this scenario remains purely hypothetical and raises myriad questions regarding the laws of thermodynamics. Even in the realm of cosmology, the arrow of time is pivotal. The universe began with the Big Bang, an event characterized by extreme heat and energy. Over time, as the universe expands, it cools, leading to increased entropy. This movement toward disorder governs the fate of the universe. Ultimately, as stars burn out and galaxies drift apart, we may find ourselves in a heat-death scenario where all energy is evenly distributed, resulting in a cold, dark universe devoid of meaningful events. The idea of the arrow of time not only affects our scientific understanding but also our philosophical musings. What does it mean for our choices, our memories, and our lives if this flow of time is unidirectional? Can we learn to embrace the present moment, knowing that the past is immutable and the future uncertain? The exploration of time, therefore, becomes not just a scientific endeavor but a deeply personal one. As we ponder this cosmic journey, let's consider how different cultures have interpreted the arrow of time. Various indigenous cultures view time cyclically, where the past, present, and future are intertwined. This contrasts sharply with the linear perspective dominant in Western thought. In conclusion, the arrow of time is a manifestation of entropy and the fundamental laws of physics, shaping both our universe and our experiences within it. As we move through time, we must grapple not just with its scientific implications but also with its existential significance. What does the journey of time reveal about our lives and the choices we make? Time travel captivates the imagination. The ability to leap through time, to visit the past or glimpse the future, is a theme that has pervaded literature, films, and scientific speculation. But how plausible is time travel from a scientific perspective? First, consider the theories proposed by physicists regarding the possibility of traveling through time. Albert Einstein's theory of relativity provides the foundational understanding of time as a dimension intertwined with space. His equations suggest that time is not a constant, it can be affected by speed and gravity. When objects move close to the speed of light, time appears to slow down for them, a phenomenon confirmed by countless experiments, including the behavior of particles in accelerators. This leads us to one of the most fascinating implications of relativity, the concept of closed time-like curves, or CTCs. These hypothetical constructs allow for paths through spacetime that curve back on themselves, essentially creating loops in time. The possibility of CTCs raises tantalizing questions. If one could travel along such a curve, could they return to an earlier point in their own life? In the 1970s, physicists Kip Thorne and others explored these ideas, weaving them into the fabric of science fiction. Thorne's work on wormholes, hypothetical passages through spacetime, showed that if these tunnels exist, they might allow for time travel. Imagine 2 points in space interconnected by a shortcut, enabling instantaneous travel not just through space but also through time. However, building or stabilizing such a wormhole, especially one suitable for human travel, remains firmly in the realm of speculation and theoretical physics. Further complicating the idea of time travel are paradoxes like the notorious grandfather paradox. If one were to travel back in time and inadvertently prevent their grandparents from meeting, would they ever exist? This paradox raises profound questions about causality and the nature of reality itself. Some theoretical models suggest that preventing such events could create alternative timelines or universes, seemingly allowing for the coexistence of different realities. Despite these scientific ponderings, time travel continues to be largely a fantasy. Yet, it sparks essential questions about our understanding of time and existence. Could future advancements in technology unlock the secrets of time travel? Some scientists believe that while traditional notions of time travel may be implausible, emerging concepts in quantum physics could open new avenues for exploration. As we endeavor to understand the possibilities of time travel, we also confront our inherent fascination with it. From H.G. Wells' The Time Machine to blockbuster films like Interstellar, storytellers have grappled with the implications of time travel on human lives. The allure of visiting significant moments in history or witnessing the future extends beyond mere curiosity. It connects to our deepest desires to alter our narratives and grasp our destinies. As we explore these ideas, we must ask ourselves, is time travel merely a captivating fantasy, or does it challenge our understanding of reality in profound ways? The relationship between time and consciousness is a complex interplay that has intrigued philosophers, psychologists, and neuroscientists alike. How does our perceived experience of time relate to the way we think and feel? Our minds process time in a manner that is often subjective, influenced by various factors such as age, emotion, and context. Studies have shown that our perception of time can distort significantly based on emotional states. For example, during times of fear or danger, such as a near accident, individuals often report that time seemed to slow down. This phenomenon, referred to as time dilation in consciousness, suggests that under high-stress situations, the brain may heighten senses, allowing for a greater awareness of events occurring in quick succession. Conversely, during mundane moments, such as waiting in line, time may seem to crawl at a snail's pace. This discrepancy in time perception relates to how our brain encodes experiences, emphasizing the importance of attention and memory. Dr. David Eagleman, a renowned neuroscientist, has examined this relationship and proposes that our perception of time is directly linked to the volume of information our brain processes. The more details we note, the longer the experience feels. As we grow older, our subjective experience of time often shifts. Many people report that time seems to pass more quickly as they age. This could be attributed to fewer novel experiences. New experiences tend to be more memorable, thus creating a longer mental movie of our lives. In childhood, when everything is new, time appears to expand. As we age, familiarity compresses our experiences, making time feel like it's speeding up. Cognitive scientists have also explored the concept of temporal binding, the tendency of the brain to perceive events that happen close together in time as a cohesive unit. This phenomenon is evident in how we remember sequences of events and how our minds structure narrative. Our perception of time becomes a narrative thread, connecting past, present, and future within our consciousness. As we delve deeper into this fascinating subject, the connection between time and memory becomes essential. Our memories are essentially our personal histories, intricately woven into the tapestry of time. Neuroscience has revealed that memory formation activates specific areas of the brain, allowing us to recall past events and experiences. Yet, just as our perception of time can warp, so too can our memories, which can be influenced by suggestion and the passage of time itself. Understanding time's role in shaping consciousness leads us to ponder profound philosophical questions. If time is merely a perception shaped by our consciousness, then what does that mean for our understanding of reality? Is our subjective experience of time a reflection of the universe's structure, or is it an illusion created by our minds? This exploration unleashes a cascade of thoughts about existence, reality, and our place within the cosmos. The intertwining of time and consciousness leads us to contemplate our own narratives. Are we merely products of time, or do we have the agency to shape it? The quest to comprehend the nature of time is not just a scientific endeavor, it is an existential journey that invites us to reflect on what it means to be alive and aware. As we step into the future, our understanding of time continues to evolve, shaped by technological advancements and groundbreaking theories. Scientists are exploring innovative concepts that challenge our traditional notions of time, delving into realms once thought to be purely speculative. One of the most compelling domains involves the study of black holes and their relationship with time. The event horizon of a black hole creates conditions where time behaves differently than it does in the outside universe. As one approaches a black hole's event horizon, time appears to slow dramatically, leading to questions about what happens if an object crosses that threshold. Some physicists suggest that entering a black hole could lead to an entirely different universe, one where time operates under alternative rules. Additionally, the concept of parallel universes and the multiverse theory suggests that time might not be linear at all. If our universe is but one of many, could different timelines exist concurrently? Each decision we make could spawn divergent realities, creating a tapestry of timelines that coexist. This challenges the very fabric of causality and time as we know it. Moreover, advancements in technology provide glimpses into the future of how we might experience time. Quantum computing and developments in artificial intelligence could eventually lead to timelines being manipulated or perceived in ways we cannot yet fathom. Could we create virtual environments that simulate different time flows? Technology's rapid evolution continues to alter our engagement with time, blurring the lines between reality and simulation. Philosophers and futurists ponder the implications of these advancements. How might our understanding of time shape societal structures, relationships, and our philosophies about life? As technology reshapes time's trajectory, our definitions of consciousness and existence may also undergo a transformation. What does it mean to live in a world where time can be perceived differently, or where technology allows for distortion of temporal experiences? In science fiction, we often encounter themes that explore these possibilities. Narrative pathways in films like Inception and Interstellar depict time manipulation as a tool of exploration, grappling with the philosophical and ethical dilemmas inherent in such capabilities. As we venture deeper into the future, these stories reflect our fears and aspirations, painting a complex picture of how time might shape our collective future. As we consider the trajectory of time, we must ask ourselves, are we on the brink of a new understanding? Is our current perception of time as linear merely the stepping stone to a more complex, multidimensional understanding? The future of time is not just a question of science, it is an inquiry into what it means to exist within the ever-evolving cosmos and our place within it. As we conclude our journey through the science of time, we reach a crucial intersection between science and philosophy. Time is not merely a scientific construct, it represents a profound aspect of our existence that invites deeper contemplation. From ancient philosophers to modern thinkers, the inquiry into the nature of time has been a path toward understanding our place in the universe. Philosophers like Immanuel Kant argued that time is a framework that our minds use to organize experiences. He viewed time as an a priori intuition, a fundamental way our consciousness interacts with the world. This perspective raises questions about the nature of objective reality and our subjective experiences. If time is a construct of consciousness, what does that mean for our understanding of reality? Throughout history, different cultures have approached the concept of time in unique ways. For instance, some Eastern philosophies consider time as cyclical, a continuous flow of rebirth and renewal. In contrast, Western thought often views time linearly, as a progression from birth to death. These differing perspectives shape our understanding of existence and influence how societies construct meaning within the temporal framework. Moreover, the existential implications of time are essential. As we confront our mortality, the finite nature of human life becomes apparent. Time serves as a reminder of the temporality of our experiences and relationships. How does this understanding influence how we live, love, and pursue our passions? Are we making the most of our time, or are we prisoners of our circumstances and distractions? As we reflect on our exploration, the philosophical implications of time resonate deeply with our identities. In a world dominated by the clock, where we often find ourselves rushing, how can we cultivate a deeper appreciation for the present moment? Mindfulness and philosophies centered around being present encourage us to engage fully with our lives, contrasting sharply with the relentless pursuit of efficiency that modern society often demands. The exploration of time leads us to consider our legacies, what we leave behind as we navigate the flow of time. It prompts us to ponder our impact on future generations. What stories will remain? What truths will transcend time? Through the lens of time, we can explore our roles as stewards of the planet and custodians of our collective history. As our documentary comes to a close, we invite you to reflect on your relationship with time. How do these concepts resonate with your experience? Are there moments in your life where time feels different? The journey through the science of time is not just a quest for knowledge, it's also an exploration of what it means to be human, to exist, to experience, and to reflect within the vast tapestry of time. Time is a crucial component of the universe, intricately woven into the fabric of space and matter. To understand its role, we need to explore the relationship between time and the universe's structure. When we look up at the night sky, we are gazing into the past. The stars and galaxies we see are not just twinkling lights, they are historical markers, their light taking millions or even billions of years to reach us. The light from the nearest star, Proxima Centauri, takes over 4 years to reach Earth, meaning we observe it as it was in the past. This phenomenon is known as cosmic time, an essential element in understanding how the universe evolves. The concept of cosmic time extends beyond simple observation. In the realm of cosmology, time and space are interlinked through general relativity, a theory formulated by Albert Einstein. According to this theory, massive objects like stars and planets warp the spacetime around them, causing time to move slower in their vicinity. This warping effect is not just theoretical, it has been confirmed through various experiments, such as observing atomic clocks on GPS satellites, which tick at a different rate than those on Earth. This interplay of time and gravity leads to some fascinating cosmic phenomena, such as black holes. At the event horizon of a black hole, time appears to stop for the observer, while outside observers see time proceeding normally. This dichotomy poses profound questions about the nature of reality. How does time's flow differ depending on location and mass? Scientists have been grappling with this question, exploring the implications for both theoretical physics and our understanding of the universe. Additionally, the expansion of the universe has a direct impact on the concept of time. As galaxies drift apart, the time it takes for their light to reach us stretches, giving rise to a universe that is not only expanding in space but also in time. This expansion signifies that time itself is moving forward, but at different rates across various regions of the cosmos. In this chapter, we will also delve into the life cycle of stars and how time influences their evolution from nebula to supernova, shaping the universe's structure and the formation of planets, including our own Earth. Stars live transient lives, with time dictating their birth, evolution, and death, leaving behind elements that contribute to the cosmic tapestry. As we explore these cosmic phenomena, we will uncover how time affects not only the large-scale structure of the universe but also the small-scale processes that drive chemical reactions and biological life, creating an intricate dance of time that flows through the cosmos. So, as we look to the heavens, we should ask ourselves, how much of our understanding of the universe is truly bound by time? From the sundials of ancient civilizations to the atomic clocks of the modern day, our journey to measure time reflects the evolution of human ingenuity. The quest for precision has led to remarkable advancements in technology, allowing us to capture and define time in ever more nuanced ways. But what does it mean to measure time? It goes beyond mere seconds, minutes, and hours. It encompasses the nature of events, their duration, and the intervals that separate them. Historically, various cultures devised methods to track time based on their environment. The Egyptians, for example, used shadow clocks, while the Babylonians divided the day into smaller units based on their lunar calendar. These early timekeeping efforts laid the groundwork for more sophisticated systems, culminating in the mechanical clocks of the Middle Ages. These groundbreaking inventions gave humans a newfound ability to segment their lives into precise intervals. The introduction of pendulum clocks in the 17th century marked a revolutionary leap in measurement accuracy. Invented by Christian Huygens, the pendulum allowed clocks to achieve a level of precision previously unseen. This innovation fundamentally altered how people interacted with time, bringing about an age of punctuality that shaped societal structures, from work hours to transportation schedules. As technology advanced, so did our understanding of time's fundamental nature. In the mid-20th century, the invention of atomic clocks transformed our concept of time measurement. Atomic clocks use the vibrations of atoms, such as cesium or rubidium, to keep precise time. These devices are so accurate that they can measure time to within a billionth of a second. This precision has profound implications, not only for navigation systems like GPS, which rely on accurate time calculations to determine positions, but also for the synchronization of global financial markets and telecommunications systems. Yet, as we reflect on this journey of technological advancement, we must also consider the philosophical questions that arise. With the ability to measure time with such accuracy, do we lose the essence of living in the moment? Are we now prisoners to the clock, constantly racing against time? Moreover, the development of timekeeping technologies has spurred scientific inquiries into the nature of time itself. Researchers explore questions like, is time linear, cyclical, or perhaps even relative? The quest to measure time has thus become intertwined with our understanding of the universe, leading to discoveries that challenge our perceptions of reality. As we move through this chapter, we will highlight the lives of key figures such as Huygens, Albert Einstein, and Niels Bohr, whose contributions shaped the field of time measurement and our understanding of time's complexities. What revelations lie ahead as we push the boundaries of our timekeeping technology? Time profoundly influences our behavior, emotions, and perceptions, yet we often take its passage for granted. Psychological time is our subjective experience of time, which can differ dramatically from the objective measurements of clocks. Consider a child waiting for their birthday. The days seem to drag on interminably, while adults might find that time slips away in a blur of responsibilities and obligations. This phenomenon highlights how emotional states can distort our perception of time. Psychologists have studied this aspect extensively, revealing that time can stretch or contract based on context and emotion. Researchers in cognitive psychology have shown that our perception of time can be altered significantly by various factors, including age, attention, and emotional states. For instance, time seems to speed up as we age, a phenomenon often referred to as time compression. This perception may stem from the fact that novel experiences, often more common in youth, create more robust memories, making time feel lengthier. As we grow older and fall into routines, days meld into one another, creating a sensation of time flying by. An example of this can be seen in the famous story of the time flies phenomenon during vacations. When people are fully engaged and experiencing something new, their memory retention creates a sense that time was longer, despite its objective passage. Conversely, when a person is bored or uninterested, moments can feel agonizingly slow. The implications of these findings extend beyond psychology. They touch on fields such as education, marketing, and even therapy. Understanding how people perceive time can influence how we design educational programs or marketing strategies. For example, advertisements that evoke strong emotions are likely to leave a more significant impression on viewers, as they are more likely to remember experiences associated with intense feelings. Additionally, this chapter will explore the concept of time and mindfulness. Mindfulness practices encourage individuals to be present in the moment, which can enhance one's experience of time. By focusing on the now, we can counteract the feeling of time slipping away and foster a deeper appreciation for our lived experiences. Finally, we will examine how different cultures perceive time and its impact on their behaviors. Some cultures view time linearly, while others embrace a cyclical concept, reflecting their values and lifestyles. This cultural lens shapes how individuals relate to time in their daily lives, influencing attitudes toward punctuality, work-life balance, and even relationships. As we navigate the complexities of psychological time, we must ask ourselves, how can we harness our understanding of time perception to enhance our quality of life? Imagine this: two events occur at the same time, yet for two observers in different locations, the timing appears completely different. This is the essence of simultaneity as framed by Einstein's theory of relativity. It challenges our fundamental understanding of time and events in the universe. Relativity tells us that time is not absolute, it is relative and can vary for different observers. To illustrate this, consider the famous thought experiment involving a train and two lightning strikes. Picture a train moving at high speed along a track. As two lightning bolts strike the track at the front and back of the train at the same time, a stationary observer on the ground perceives both strikes occurring simultaneously. However, for someone on the train, things are different. Due to the speed of the train, the observer on board sees the lightning strike at the front of the train first, followed by the strike at the back. This difference in observation leads to a profound realization: simultaneity is dependent on the relative motion of the observers. This concept has deep implications in physics, suggesting that time cannot be viewed as a universal constant. Scientists have conducted experiments using atomic clocks on fast-moving jets, showing that time indeed flows differently depending on the speed and gravitational field. In these experiments, clocks at different altitudes or velocities can measure significantly different times. The implications of the relativity of simultaneity extend beyond theoretical musings. They have practical applications in our everyday lives, especially in GPS technology. This system relies on satellites that orbit the Earth at high speeds and different gravitational fields. To provide accurate positioning, the system must account for both special and general relativity. Without these adjustments, GPS calculations would drift significantly, leading us far from our intended destinations. Thus, the relativity of simultaneity not only reshapes our understanding of time but also influences the technologies that underpin our modern world. As we dive deeper, we will uncover how these insights into the fabric of time challenge our perspectives on reality itself and the universe we inhabit. But what does this mean for the concept of causality? Will our understanding of cause and effect unravel under the scrutiny of time relativity? Stay tuned to find out. What if I told you that our understanding of time cannot exist without space? This is the profound reality of the fabric of the universe, known as spacetime. According to Einstein's theory, time and space are not separate entities, they form a unified four-dimensional continuum. This revelation reshaped the study of physics and cosmology, bringing forth questions that challenge the foundations of reality. To grasp this interrelationship, consider the way gravity operates. The heavier an object, the more it warps the fabric of spacetime around it. Imagine a trampoline. When a heavy ball is placed at its center, the surface dips significantly. Similarly, massive objects like planets and stars create indentations in spacetime, causing nearby objects to follow curved paths. This is gravity in action. Moreover, the effects of this warping become evident in the phenomena of time dilation. For example, near a black hole, where gravity is immensely powerful, time flows slower compared to a distant observer. This creates an intriguing scenario. If you were to hover close to a black hole for an extended period and then return to Earth, you might find that years, or even centuries have passed, while only a few hours elapsed for you. This intricate dance of time and space leads us into the realm of theoretical physics, particularly discussions around the universe's expansion. The Big Bang Theory proposes that the universe began from a singular point and has been expanding ever since. As spacetime stretches, it raises intriguing questions about the nature of time itself. Astrophysicists like Stephen Hawking have suggested that if we rewind the expansion of the universe, we may find that time itself also reverses. This idea morphs into speculative discussions about the cyclical nature of time, where the universe might undergo cycles of birth, death, and rebirth. However, these theories also confront us with unsettling paradoxes. Has time truly always existed, or is it merely a product of our universe's existence? As we ponder these questions, we must also consider the implications of spacetime on our existence. How does this intertwined nature affect our understanding of life, destiny, and the universe? What are the philosophical ramifications of recognizing that time is not linear but rather a delicate weave with space? The journey through spacetime poses more questions than answers, leading to a deeper exploration of reality itself. Join us as we unravel these profound connections and their significance to the very essence of our existence. Time is not just a scientific concept, it is deeply woven into the fabric of our cultures and societies. Different civilizations throughout history have perceived and valued time in diverse ways. From the calendars of ancient cultures to modern timekeeping, each society has developed its unique understanding that reflects its values and beliefs. Take, for instance, the ancient Maya civilization, renowned for its advanced astronomical knowledge. They created a complex calendar system that divided time into cycles, reflecting their understanding of the cosmos. The Maya believed that time was cyclical rather than linear, a view mirrored in other cultures, such as the indigenous peoples of North America. Their perspective emphasizes harmony with nature and the rhythms of the earth, contrasting sharply with the linear timeframes of the Western world. As we look to modern society, timekeeping has become a standardized practice. The invention of mechanical clocks in the 14th century marked a significant transition, enabling precise measurement and regulation of time. This shift not only affected daily life but also transformed industries and economies, leading to the rise of capitalism and the modern work ethic defined by punctuality. However, the relentless march of time as a commodity raises issues. How does the contemporary obsession with efficiency and productivity impact our mental health and social relationships? Studies reveal that societies that prioritize time management often struggle with stress and anxiety. The accelerating pace of life can create a disconnect between individuals and their environment, where the focus on schedules overshadows the natural flow of life. Additionally, the digital age has introduced new dimensions to our understanding of time. With the advent of instant communication and information, we experience a simultaneous global consciousness that blurs the lines of local time. The concept of real-time interactions has influenced our perception, leading to an expectation of immediacy that affects interpersonal dynamics and social norms. But what happens when this obsession with time clashes with cultural practices that value slower, more deliberate experiences? As global cultures collide, we find ourselves at the crossroads of tradition and modernity. Will we adapt to this accelerated timeline, or will there be a resurgence of the appreciation for cyclical time? The answers may reveal much about who we are as societies. Join us as we explore these nuanced intersections of time and culture, questioning how our understanding shapes our lives and futures. When we think about time, we often perceive it through the lens of our daily experiences, our schedules, and the ticking of clocks. But what if we told you that our understanding of time is minuscule when placed against the vast canvas of the universe? In this chapter, we will explore the cosmic scale of time, examining how time differs extraordinarily in the context of astronomical phenomena. Consider for a moment the life cycle of a star. Our Sun, a relatively young star at about 4.5 billion years old, is merely a toddler in the timeline of the universe. It is expected to burn for another 5 billion years before eventually exhausting its nuclear fuel and transforming into a red giant. The entire life cycle of a star from birth to death spans billions of years, completely beyond the scope of human experience. But this isn't just about stars. The universe itself has been expanding since the Big Bang, approximately 13.8 billion years ago. This revelation forces us to confront the enormity of time as a metric, prompting us to rethink our place in the cosmos. How does time as we experience it relate to the vast stretches of time that define the universe? To illustrate this point, scientists employ the concept of cosmic calendars. If we were to compress the entire history of the universe into a single year, our own planet would not appear until the last 7 seconds of December 31st. This stark visual helps frame our existence within the grand timeline of cosmic events. Furthermore, consider the design of the universe itself, governed by physical laws that transcend our temporal understanding. The theory of relativity reveals how time can warp in the presence of significant mass, leading to scenarios where time passes differently across varying gravitational fields. On Earth, two twin astronauts, one on a space journey and the other on the surface, would age at different rates due to the effects of time dilation. This is not just theoretical, it's a reality that has been confirmed through experiments involving precise atomic clocks. As we delve deeper into the significance of time in the universe, we must also confront the ancient question of whether time itself has always existed or originated with the universe. The philosophical implications challenge our understanding of existence and reality. Could there be realms beyond our perception of time? In the vastness of the cosmos, the measurement of time, and indeed, our comprehension of it, can alter dramatically, intertwining with concepts of space and gravity. As our journey through this cosmic timeline continues, we will touch on critical events that have altered the course of time in the universe, from the birth of stars to the formation of black holes, paving the way for deeper discussions about time's future and its philosophical implications. Time isn't just a concept that exists in the wider universe, it also pulses rhythmically within us. Every living organism is in a constant dance with time through biological clocks that dictate their behaviors and functions. These internal clocks, or circadian rhythms, govern numerous physiological processes, sleeping and waking, hormone release, eating habits, and even cell regeneration. The mechanism is itself a marvel of evolution, finely tuned to sync with the environment. Research shows that our biological clocks are influenced by external factors known as zeitgebers, which include light, temperature, and social cues. Studies reveal how light exposure, especially the blue light emitted by screens, can disrupt these rhythms, impacting our health, mood, and productivity. The implications of understanding these biological clocks are profound. For instance, studies conducted on shift workers revealed alarming statistics. People who disrupt their circadian rhythms experience higher rates of obesity, diabetes, and heart disease. This underscores the importance of maintaining a healthy schedule aligned with our body's natural rhythms. We also see fascinating adaptations in the animal kingdom. Migratory birds, for example, utilize their biological clocks to navigate thousands of miles across the globe. They can sense the Earth's magnetic field and adjust their internal clocks to synchronize their journeys, showcasing a remarkable relationship between time, biology, and survival. Another area of exploration involves the aging clock. Researchers are uncovering the biological mechanisms behind aging, revealing that time impacts us not only in a chronological sense but also at a cellular level. Telomeres, the protective ends of our chromosomes, shorten as we age, eventually leading to cell senescence. This has led scientists to investigate ways to potentially extend lifespan by manipulating biological clocks. Could we harness the understanding of our inner clocks to delay aging? Promising research in epigenetics suggests it might just be possible, opening doors to extending healthspan and lifespan significantly. As we navigate this chapter of biological clocks, we will delve deeper into the astonishing mechanisms of time within our bodies, how they affect our health and wellness, and the revolutionary research paving the path towards altering our relationship with time itself. Time is not just a straight path, it's more like a complex web of possibilities, full of paradoxes that challenge our understanding of reality. What if we told you that time can behave in ways that defy logic and reason? Let's dive into some of the most captivating temporal paradoxes that have intrigued philosophers, scientists, and even fiction writers for centuries. One of the most famous is the grandfather paradox. Imagine traveling back in time and accidentally preventing your grandfather from meeting your grandmother. This would mean you could never be born, leading to a contradiction. If you were never born, how could you travel back in time in the first place? This paradox raises crucial questions about causality and the nature of time itself. If we can travel in time, does that imply a defined timeline with fixed outcomes, or do we open the door to infinite possibilities? Some theories suggest the existence of multiverses, where every decision creates a new timeline, leading to an endless array of existences. Next, we explore the concept of time loops. In science fiction, we often see characters stuck in time loops, living the same day over and over again, as in the movie. As we venture beyond our planet, we find ourselves confronting a concept that can bog down even the sharpest of minds: the vastness of time on a cosmic scale. Imagine the birth of the universe itself, some 14 billion years ago, in an event we now call the Big Bang. This event wasn't just the beginning of space but also the inception of time as we know it. Now, picture our own solar system. Formed from a swirling cloud of gas and dust, it has existed for about 4.6 billion years. But that's just a fraction of the timeline of the universe. In the grand tapestry of existence, our sun will eventually exhaust its fuel, undergoing a transformation that will take billions of years. Its death throes will lead to a nebula, which may one day spark the birth of new stars and planets, reminding us that time is cyclical. In this chapter, we'll explore how time in the cosmos affects celestial events, the life cycles of stars, and even the formation of galaxies. The universe is a dynamic place. Stars are born, live out their lives, and die over billions of years, while galaxies collide and merge, sometimes in spectacular fashion. Take the Milky Way and the Andromeda Galaxy. They are on a collision course set to occur in about 4.5 billion years. The cosmic clock runs differently based on where you are in the universe. In high-gravity areas, time moves slower than in low-gravity areas, a phenomenon we refer to as gravitational time dilation, as postulated by Einstein's theory of general relativity. This means that far out in a galaxy, time stretches and bends in ways that are incomprehensible from our earthly perspective. Consider the implications of time when we think about distances in space. For example, when we gaze at the stars, we are looking into the past. The light from our nearest neighbor, Proxima Centauri, takes about 4.24 years to reach us. When astronomers observe galaxies over billions of light-years away, they are essentially peering back in time, understanding the universe at various stages of its evolution. The light from some of the furthest galaxies we observe today left those galaxies when the universe was still young, mere millions of years after the Big Bang. The implications of this reveal just how intricate the cosmos is, a vast timeline filled with events both grand and minuscule. Yet, despite this immensity, time in the cosmos poses a future dilemma for humanity. As we ponder our own existence, we must also consider the fate of our planet and the solar system. Will we eventually become a cosmic footnote, a mere whisper in the grand narrative of the universe? As we explore these ideas, let us remember that time is far more than just an agenda or a calendar. It is a powerful force that governs the very structure of our universe. For as we delve deeper into the realms of time, we, too, begin to realize that we are indeed part of a much larger story unfolding over epochs in the vast, unyielding cosmos. As we transition into the realm of biology, we encounter another fascinating aspect of time, the biological clocks that regulate our bodies. Every living organism is governed by internal mechanisms that follow the rhythms of time, often referred to as circadian rhythms. These rhythms dictate our sleep-wake cycles, hormone release, body temperature, and other vital functions. Interestingly, these biological clocks are not only influenced by external environmental factors but also by the internal biochemistry of organisms. In humans, our circadian rhythm is approximately 24 hours long, synchronized with the day-night cycle. This synchronization is critical for optimal health. For instance, when light hits our eyes in the morning, it triggers signals to the brain to suppress melatonin production, allowing us to wake and become alert. If we disrupt this cycle, such as through night shifts or excessive screen time, the consequences can be dire: sleep disorders, increased stress levels, and even chronic diseases. Studies have shown that people who work night shifts are more prone to conditions like obesity and diabetes, highlighting the importance of adhering to our biological clocks. But the influence of time does not stop with circadian rhythms. We also experience ultradian rhythms, which occur in cycles shorter than 24 hours, such as our attention span and alertness throughout the day. Among the most intriguing aspects of biological clocks are the possibilities of temporal lobe brain functions. Research has revealed that the brain's perception of time and memory can be closely tied to how our bodies experience time. For example, during stressful or traumatic events, our brains can encode memories in such a way that they feel longer than they actually are. It's as if time expands during those moments, allowing us to process more information, which can be critical for survival. Then there's the phenomenon of time perception in different cultures and societies. Some cultures may view time as linear, while others perceive it as cyclical. This cultural lens can significantly influence how we understand time on a personal level, and ultimately how it impacts our behaviors and decisions. Additionally, consider the case of hibernation in animals, which challenges our traditional understanding of biological time. For instance, some species, like bears, can enter a state of torpor, allowing them to survive through long periods